All right. So what we see when we look at the digestive system, if you look here, we see that this is the mouth. All right. And therefore, what we see is this long tube that ends at the anus. All right. So it's safe to say that, it kind of winds around and it gets fat in one section here. But it really is just a long tube that has a beginning and has an end. All right. So when we look at it like this, it kind of puts things into perspectives. We eat food, so food goes in, and whatever is not broken down, which we're going to call the word digestion, whatever is not broken down and absorbed is going to leave the body as waste. All right. So let's think about this for a minute. I'm going to go ahead and, as we move on to our next slide, we see that the functions of the digestive system are ingestion, digestion, absorption, and excretion. So we're going to concentrate on ingestion right here. So we're going to start with this, then we're going to move into digestion, talk about absorption, and then excretion. So when we think about the word digestion, just to talk about the word for a second, we want to know that there are two kinds of digestion. There is mechanical digestion and there is chemical digestion. So mechanical digestion involves the physical breakdown of food into smaller pieces. So that's much like chewing. You're chewing your food and you're mechanically breaking it down, or you're physically breaking it down into smaller pieces. But the other end of digestion is chemical digestion. And this involves the use of digestive substances to break chemical bonds between macromolecules. So substances are broken down chemically, and then those substances that came from those macromolecules form subunits that can be absorbed. So let's think about that for a second. If you eat a cheeseburger and you mechanically break that cheeseburger down, well, just chewing it is not going to do the job. All the nutrients have to be broken down into their simplest form. So when we think about this, we want to move on to our next slide here. And we want to look at this process. So this is this digestive tube, right? And we said that food goes in through the mouth. Well, look at this word here. Look what we see. We see it breaking down into smaller parts, and what does not get absorbed is going to end as waste. But I want you to think about this right here. Digestive enzymes. And there are many, because this is what involves chemical digestion. So this is chemical digestion. And I like to say that enzymes are like a judge. They can marry people, right? Judges can marry people, but they can also divorce them. So enzymes can bring substances together, but they can also break them down. So the digestive enzymes are in charge of breaking substance down. So we see them along the way of the digestive tract. So we see physical action here, right? And then we see chemical action, all right? So in order to understand this, we want to make sure that we understand the nutrients. So this part is not in your book, and I'm going to start here. It's in your book, but it's not until the next chapter. on nutrition, which we cover in 3 weeks. So we'll go through to this week, next week, and then the following week, we'll start nutrition and metabolism. So we're going to get a jump on that. We understand what's going into the digestive system. All right. So when we think about nutrition, we want to make sure that we think about 6 nutrients. All right. So there are 6 nutrients that we want to concern ourselves with. So we have carbohydrates, we have fats, which we also call lipids, proteins, vitamins, minerals, and water. So 6 nutrients. Now, we're going to be talking a lot about these in these first, in this unit, so in the digestive unit. And then when we get into nutrition and metabolism, we'll be talking about these. So what I'm doing is I'm actually separating these into 2 categories. So carbohydrates, fats, and proteins are known as macronutrients. So these are what we mentioned in the very beginning, macronutrients. And these are considered micronutrients. So vitamins, minerals, and water are considered the micronutrients. So when we think of these macronutrients, what we think of is how are they going to break down into smaller components? Well, they need to break down into smaller components because they are energy nutrients. All right. And in saying energy, we want to realize that they have calories. All right. Vitamins and minerals and water are not energy nutrients alone. So they do not have calories. All right. So what happens is because these are energy nutrients, they are nutrients that are needed for the body to produce energy. A lot of people get confused with vitamins and minerals because they think, oh, if I take my B vitamins, that's going to give me energy. Well, what we have to realize is that they are not energy alone. Vitamins and minerals assist in the energy, in the making of energy. So it's important to have them, much like it's important to have water for fish. All right, so let's go back and let's clear this page, and we're going to start talking about these macronutrients. So the very first nutrient that we want to talk about is carbohydrates. And when we think about carbohydrates, we often think about things like starch, and we think about bread, bread is starch. But we have to remember that things like sugars, like table sugar, that is carbohydrate. Sorry, I've got a little frog in my throat. So table sugar is carbohydrate. So we have many different types of carbohydrates. And before we go too far with examples, let's start learning about them individually. So monosaccharides, what monosaccharides are glucose, galactose, and fructose. So we have glucose, galactose, and fructose. Mono means one, all right? So what this means is that these are single sugar units. Right? So if we think about that, we have a single sugar unit, not connected to anything else. So we're going to build all our other sugars from these single sugar units. So let me explain how this is going to work. If we had blocks, let's say that we had these blocks, and we had an A block, we had a B block, and we had a C block. And I told you that you are going to get a lot of A blocks, just a few B blocks, and just a few C blocks, all right? But this is going to be your main block. You're going to be using this every time you build, all right? So you might build like this. You might have an A and a B, and you might have an A and an A, right? Because you have lots of A's, all right? And you might have an A and a C, all right? So no matter what, you could build, you know, whatever you wanted to build, but you only had these 3 blocks, all right? Well, that's how the body kind of considers the sugars, all right? So when we think about this, glucose would be number 1, really, because glucose would be like that A block, all right? You're going to have a lot of that. We're going to take in a lot of glucose when we take in sugars. So glucose, this is really king. We're going to say that this is blood sugar, all right? And galactose is part of milk sugar, all right? And fructose is fruit sugar, all right? So regardless of, you know, whether it's glucose, galactose, and fructose, these 3 sugars are single sugar units, just like single blocks. And they are in their simplest form. So if you're breaking something down, then we would, you know, thinking about the blocks, if we were breaking this down, we would break it into the individual A, B, and C blocks. And if we break a substance down for the digestive system in regards to carbohydrates, we would break it down into these simple sugars for absorption, all right? So disaccharides are not so simple. Disaccharides, di meaning 2, all right? So di equals 2. Disaccharides are 2 sugar units connected together, all right? So we're going to say that they are 2 sugar units connected. So the sugars that we find with disaccharides are sucrose, lactose, and maltose. Sucrose, directly, this is table sugar. Lactose is milk sugar. So that's the sugar that we find in milk. And maltose is plant sugar. So we're just gonna say that it's plant sugar. It's a type of sugar if you talk about malt, all right? So what we know is that these sugars, these 3 sugars, are going to be connected to, it's going to connect 2 sugar units together. So let's see what that's going to look like. So in order to do this, I'm going to give these abbreviations. So we're going to say that glucose is G, this is GA, all right, and fructose is F. So let's take our blocks here and let's make 2 sugar units. So sucrose is very sweet. So if we were to think of these sugars up here, I think that most people would think that fructose is probably one of the sweetest. So we know that this is table sugar. So we have a fructose and we have a glucose. All right. So fructose and glucose together, we have 2 sugar units make up sucrose, right? So let's put in our glucose here and let's put in our fructose. And we know that these 2 sugars are bound together to make sucrose. Lactose, well, this is easy because we already know that lactose is part of milk sugar, right? So let's put our galactose in there, right? So galactose is part of milk sugar. And then we have another sugar unit and we're going to have glucose, all right? So maltose is 2 glucose units connected together. All right. So remember that these disaccharides, these are foods we eat. We really don't talk about eating glucose, galactose, and fructose because they live more in these disaccharides as, you know, these double sugar units. So when we eat sucrose, we get glucose and fructose. And when we drink milk and we drink lactose, we get galactose and glucose, type of carbohydrate. And this type of carbohydrate is a polysaccharide. All right. And a polysaccharide has many sugar units. So poly, word poly, equals many. All right. So remember, we said we had lots of A's, lots of glucose. So we're going to connect all of these together and make a polysaccharide. So a polysaccharide is many glucose units. Okay. So when we think about this, we know that this is foods like starches. Okay. So if we have things like starches, like bread and cereals and things that fall into this category, even some, potatoes, things, that are natural. So if we look at how different this is from this, we see that the difference is that we have these bonds. So what we have to think about is if this is what gets absorbed, how are we going to get this from this? Well, remember I mentioned enzymes in that one slide. And what I said about enzymes was that enzymes were in charge of chemical breakdown. So the enzyme for sucrose is sucrase. And the enzyme for lactose is lactase, all right? And the enzyme for maltose is maltase. So what happens is that these enzymes are available in the brush border. I'm just going to write BB. So in the brush border of the small intestine. And these enzymes are needed to break these into our individual components. So in our next unit, we're going to see how these enzymes are actually working. But for right now, what we want to think about is that the job of the digestive system when we eat sucrose, lactose, and maltose is to break these down into these simpler forms so that they can be absorbed. So these sugars are what's absorbed. So let's think about this, and if you can, go ahead and take a picture when I'm finished, so that you have this, and you can go back and look at this when you are finished. So hopefully everybody is taking notes as well. So when we think about the polysaccharides and we think about starches, we think about this next category. So the enzyme that is needed to break down these starches, because think about this, these starches are going to need to break all the way down to these single glucose units. So we want to know the enzyme that is going to break them down. So the enzyme is amylase. And amylase is going to come not from the brush border, but it's going to come from salivary glands. And we're also going to see that it's going to come from the pancreas. All right. So amylase is going to come from salivary glands and the pancreas. So because this is such a large, complex molecule, it's not going to break down all at once. It's going to need a couple chances to break down. Is there any questions about carbohydrates so far? No? So which enzyme is needed for glucose?
Amylase.
Okay, so that's actually a trick question because glucose does not need any enzymes because it's already in its simplest form. But you know what? I am glad you said amylase. So we're going to move on to our next slide, and we're going to go to the drawing board for a second. So does everybody have this down?
Yeah.
All right, so I'm going to go ahead and clear this. And I am going to take you over to your drawing board. And that didn't go too smooth. So you know what? I'm going to stay right here. So I'm not going to transition. All right. So let's think about this. Can everybody still see my screen?
Yeah.
All right. So he said amylase. And one thing that we just, we said was that polysaccharides require amylase as an enzyme to break them down. So if we have this string of glucose, let's say we've eaten a piece of bread and we have, these polysaccharides that we've eaten. Well, what's going to happen is that these are going to break down into disaccharides, right? And if we're thinking of a disaccharide that has two glucose units, which one would it be? If we think of a disaccharide that has two, remember we had sucrose, lactose.
Is it maltose?
It's maltose,
Maltose.
yes.
Maltose.
It's maltose. So maltose has two glucose units. So with the amylase, what's happened here, all right, is it's actually broken down into these, these maltose units. So then what's going to happen is maltose is now going to break down these sugars into their final glucose units. like this. So we have glucose, glucose, and glucose. And we'll talk about later how these enzymes are working. But, you know, just as for the concept right now, these are what's going to get absorbed. All right. So we have these glucose units absorbed. So this is all glucose, right? So what was the enzyme that's going to break maltose down into single glucose units? What's that enzyme? So that enzyme is going to be maltase. All right. And maltase is going to come from the brush border of the small intestine. All right. So now what that gives us is it gives us the, you know, the glucose units, which can be absorbed into the small intestine. So this is the job. This is chemical digestion, because it's breaking these substances down from these large molecules that we've eaten all the way down to these small molecules that can get absorbed. All right. What do you think happens if we don't produce these enzymes? What do you think happens? And think logically.
You said if they don't.
Let's say that we're not producing these enzymes, our intestines are not producing these enzymes. You know, what happens if these enzymes are not produced? Remember, this is chemical digestion.
We'll have too much chemicals in our body.
So what's going to happen is they're not going to break down, right? So I want you to think of, you know, this is what we're looking for. We're looking for these simplest forms of the nutrients, all right? So you've eaten this, and when you've eaten this, it's gone into this digestive tube, right? So let's say that we ate bread, and bread was a carbohydrate, all right? And our goal of this bread, because we know it's a polysaccharide, right? So we've eaten this polysaccharide, and we want it to break down to a disaccharide and then into these single glucose units so that it can get absorbed. I'm just going to write the letter A for absorption. We want it to be absorbed into the bloodstream. All right. So we want it to be absorbed into blood vessels. But what happens if this is the digestive system here, all right? And like I said, think about it logically. If this is the digestive tube, all right, so this is the digestive tube. What happens if it never breaks down? Because we require enzymes here.
It stays right there.
It does. And then what's going to happen?
No poop.
So it's going to make us, it's going to constipate us. It's going to wreak havoc on the large intestine. So we need to break down our food. It's going to wreak havoc on the whole system. Does that make sense? And
Yeah.
sometimes when food doesn't break down, it can wreak havoc in a way that it's overfeeding the bacteria in the system. We really want everything breaking down and moving through. Does that make sense? So think of a baby. A baby doesn't normally produce enough amylase to break down starch. So when we start to give them cereal too early, you know, a lot of times mom would say, you know, put a little cereal in their milk and they'll sleep like a baby. Well, or they'll sleep like a baby. They are a baby, they'll sleep sound. So what happens is that because a baby up to the age of 4 months really isn't producing enough amylase, well, that's going to thicken their stool. It's going to, you know, it's going to weigh down their digestive system. And yes, they are going to sleep because they're exhausted from this activity. Does that make sense? So sometimes with babies, the doctor will tell the mother to do this if they have reflux, to weigh it down. So think about that. The job is of the digestive
Is that
system.
why they give, like, well, I know my aunt, she gives my cousin goat milk instead of like milk, like, because I guess goat milk is better to digest.
Well, that would not be a carbohydrate issue. That would probably be a protein issue. So cow's milk versus goat's milk, that, they may find, I'm not sure. I don't want to say that I'm sure why they're doing that, but that would be a thought, that it would be a protein. Sometimes people are allergic to, the different substances found in milk. So the protein being one. But the job here is to really break it down. So we don't want to feed starch and carbohydrate too early, just in general, because we know that those enzymes aren't present until about 4 months. Does that make sense as to what we're talking about with chemical digestion?
Yeah.
For carbohydrates. So you want to remember these categories, and you want to remember what makes up these categories. So just to go back one more time, I'm just going to write these in because we did a lot of writing on the page. The monosaccharides were glucose, galactose, and fructose. So these are the single sugar units that get absorbed. The disaccharides were sucrose, lactose, and maltose. And the polysaccharides are things like, we're going to see that they make up, I'm going to throw a few words in here. Polysaccharides make up glycogen. Oops, I wrote that wrong. I wrote glycose. Sorry about that. We'll talk about glycogen a little bit later in the metabolism unit, but just let's throw this in here. So there's starches. Let's go back and write their starches. We see that we have fibers, and then we have glycogen that are going to make up these categories. All right. So this is mainly what we talked about today. All right. Just to make a note about the fibers here. Fibers are very unique. So hopefully everybody has written this down. I'm going to clear this page one more time, and I am just going to talk about that. So fibers are found in foods like apple pectins, and some of our fruits. We find fibers and in natural foods. So we need to get fiber every day in our diet. And the one thing about fiber is it does fall into the polysaccharide unit, but there are no enzymes. There are no natural enzymes for fiber. All right. So what do you think that means? If there's no natural enzymes for fiber, what would that mean to you? So I want you to think about that digestive tube again. All right. And we've just eaten something like an apple. We have fiber in an apple. And here's our fiber. And our fiber there's no enzymes. What happens? So fiber does not get absorbed. And what happens is fiber is important because it's going to feed the intestinal needs. So it stays in the intestine, and what it does is it feeds the organisms within the intestine, but also it helps to fiber. It can hold water, so it bulks the stool. So we say that it bulks and softens stool. So it falls into the carbohydrate chapter, but what happens is that when we look at this here, we know, or the carbohydrate unit as a polysaccharide, but what happens is we know that those bonds with fiber are different from the bonds that we see with other polysaccharides. So there is no enzyme here for fiber. But it's important to eat within your foods along with water. You want to make sure that when you eat fiber that you're getting plenty of water. And that helps to bulk and soften stool. Okay. So let's go back to, or let's go not back to, but let's go on to our next macronutrient. And our next macronutrient is protein. So when we eat proteins, we eat foods like we eat meat, we eat eggs, soy, nuts, seeds. All these things contain proteins. And what we really want to say is that they contain amino acids. So we're gonna give this a word. So let's say that we have a complete protein. So my word is complete protein, all right, or my words. And when we think of a complete protein, we think of a protein that contains all essential amino acids. So when a protein food contains all essential amino acids, we call that food a protein source, like meat, like eggs, soy, nuts, seeds. And we really like to see all of these things eaten together if possible. So some rules have changed with that. We'll talk about that in the nutrition unit. But when we eat these foods, we are getting essential amino acids. So when we think of essential amino acids, these are, there's 10 essential and 10 non-essential. And I want you to think about this. I'm just going to give you an example. I'm going to do a little diversion here. I want you to think about the alphabet. Oops. Sorry about that. I did not mean to go there. Shoot. I hit the share button and all right. So I want you to think about the alphabet. And when you think about the alphabet, let's think about, we have Shelby online here. So let's think about let's think about Shelby's name. Do you care if I use your name, Shelby?
No, that's fine.
Okay. All right. So we have the name Shelby, right? And we know that in the alphabet, there are 26 letters that make up the English language. All right, so 26 letters that make up the English language, all right? And within the English language, we have names. So we're going to use the name Shelby, all right? Of those letters, we know that A, E, I, O, and U are essential, right? They are essential because they are the valves, right? So without these valves, we cannot make words, right? So Shelby, so it's A, E, I, O, and U, and sometimes Y, all right? So Shelby has the letter E in her name as a vowel. So she has an essential letter. So what would happen? Could we read her name without that letter E? It would not look the same, right? So we need this essential letter. All right. So where I'm going with this, I'm going to go ahead and clear some of this, is that our bodies formulate specific proteins which are needed to make specific substances. So our cells have a blueprint for things like enzymes and things like hair and skin and nails and hormones, all made of proteins. Well, that blueprint for those substances is specific, just like the blueprint that contains there's a blueprint for the name Shelby. We have to have an S, an H, an E, an L, and a B. Well, we have to have these amino acids in order to make body proteins. All right. So these are found in food. So let's go back here. Whoops, I started with the wrong letter there. And what we know about these essential amino acids is that they are found only in food. All right. And those foods are called protein foods. Well, these are found. These are, I should have this picture up here. Sorry about these. These are found in the body. So the body makes these. All right. So if we're thinking about the name here, Shelby, right? Let's say that these are made by the body. So we have plenty of these here. All right. But this one we have to eat. And without it, it's crucial. Does that make sense? I know I'm using a different kind of example, but does that make sense?
Yeah.
So what happens when you do not eat protein foods? Well, we become protein deficient. And remember, very important substances are made from those important enzymes that are contained in those protein foods. So be careful, especially those of you who have children out there, because we need good, healthy protein sources in order for our kids to grow. So we need good, healthy protein sources in order for our bodies to maintain themselves. So we say that these are the building blocks of proteins. So amino acids, let me write that down. Amino acids are the building blocks of proteins in our body. So if we need to repair ourselves, if a patient in the hospital sees a dietitian and the dietitian comes in and says, I need to get you to eat some protein. So that's essential because what they're thinking about is things like muscle tissues maybe breaking down. We need to start to rebuild our body. We need to maintain our body, and we need to consider this during growth. So when we think about this, I'm going to go ahead and clear this page. We eat these proteins, and then what we want to think about, okay, so like a steak, I need to break that down. What is going to, Hey guys, sorry about that. Is everybody still with me?
Yeah.
Okay.
Yeah.
All right. Okay. So so when we're looking at these polypeptide chains, all right, what we're looking at is we're looking at like chains of amino acids. So let's go ahead and put our, and we're not going to talk about specific amino acids until we get to that unit on nutrition and metabolism. But what we are talking about is that there's essential and non-essential. So what I want you to understand is that when you eat these protein foods, you eat these, these amino acids that are needing to break down. So it's really kind of the same concept. So what happens is that they break down into smaller chains, right? And then eventually we have amino acids, we have single ones. So we really need to get back in from these these chains of amino acids into the simplest form. So if you think about amino acids and you think about like letters of the alphabet, well, you can form anything from that, and your body needs to form specific proteins that make up you. So we need to eat these proteins, we need to break them down, and we need to let the body do its work. It needs to absorb these amino acids. So when you think about this, we want to know what enzymes are important, because we're covering the digestive system in this process. And the answer to that question is that proteins, they really begin to digest in the stomach. So when you eat proteins, you want to make sure that you have good mechanical digestion first. You want to make sure that you're chewing your food well. So they begin to break down in the stomach, and the enzyme in the stomach is called pepsin. So what we're going to see is that pepsin is an enzyme that was converted from another substance called pepsinogen. All right. So in the stomach. So I'll explain that a little more in just a second. So we see that, we know that protein digestion begins in the stomach, and that we're going to need pepsin in order for it to break down. All right. So that's not the only place that it's, because it's not going to break it all the way down. We're going to need some pancreatic enzymes. So the pancreas produces proteases, and we're going to look at that class of proteases, all right, which is a class of enzymes, including the proteases are protein enzymes, but there's more proteases that are produced by the pancreas that are going to allow for breakdown. So this is the goal. This here is the goal, is to break them all the way down so that they can be absorbed. So if we were thinking of this here, let's think like we have the name Shelby, right? And we break it down a little bit, and then we break it down like this. All right. And we can use these individual letters. Does that make sense? So what's going to cause that breakdown is going to be enzymes. So let's think about this here. So we've talked about the pancreas twice now. So if we have this digestive tube here, right? And we've looked at the esophagus, because we know that that's on the back of the trachea, right? We have the stomach here. And then here we have the beginning of the small intestine. So I'm just going to write SI there. Okay. So what happens here is that we take in this food goes in to the mouth, and to this point we know that carbohydrates, so we're going to write carbs, begin to break down chemically. So they begin to break down in the mouth. All right. So only polysaccharides though. So polysaccharides are the ones that begin to break down in the mouth. And that's because we have amylase. So I'm going to write my enzymes in white. So we have amylase coming from salivary glands, which we mentioned. So carbohydrates are really the only food that are going to begin to break down in the mouth. There is some lingual lipase in the mouth that's going to be for fats later, but the lingual lipase is not as effective, and we'll understand why when we get to that part. In the stomach, we have pepsin, which is going to break down protein chemically. And then what we've talked about to this point is we've talked about the pancreas. And the pancreas lives partially behind the stomach, mostly behind the stomach. So here's the pancreas. And what it does is it secretes its contents onto, there's a duct here, pancreatic duct, onto the small intestine. And for digestion, it is known as an endocrine organ. Sorry, exocrine. So it's an exocrine organ, but also an endocrine organ. Its exocrine organ is enzymes, because it's not going into the blood, but into the digestive system. So then what we talked about to this point is that the pancreas produces amylase for carbohydrates, but also proteases. That says proteases. So, but also proteases for proteins. So this is for carbohydrates, and this is for proteins, two of the very important energy nutrients. Does that make sense? So we're going to learn about glucose. Glucose is very important for brain function. In fact, the brain functions on glucose as a nutrient. And we've learned that proteins are so important because we need those for growth and repair and, important substances such as enzymes and hormones. But we need them in their simplest form. We don't need them in their food form. We need the nutrients in their simplest form. And the simplest form is going to occur because of these enzymes that are chemically breaking down our foods. So the proteins, so the, two of those major nutrients are broken down from the pancreas. We're also going to see that the pancreas produces a third enzyme and for nutrition, and that third enzyme is lipase. So we have amylase, proteases, and lipase. And lipase is going to be needed for fat, which is our third energy nutrient. If your pancreas is not healthy and you have, pancreatic issues, we need to worry about breaking down our foods and absorption of those foods. Is there any questions? All right, so let's go on to our next nutrient. And our next nutrient is fat. So remember, our macronutrients were carbohydrates, proteins, and fats, and we're talking about breaking them down chemically. So we have different types of fats. We have, monounsaturated fats, polyunsaturated fats, and saturated fats. And when we eat fat in foods, we know that it can be either liquid at room temp. So these two are liquid at room temp, or it is solid at room temperature. Okay, hold on for 1 second. So when we're thinking about these foods, they're either liquid at room temperature or they're solid at room temperature. I want you to think about your oils. All right. So oils would either be monounsaturated fats or they would be polyunsaturated fats. So monounsaturated fat, an example of that would be like olive oil. And your olive oil sits in your cabinet and it never solidifies completely because it's a monounsaturated fat. So here we have like our soybean oils as polyunsaturated fats. And that is like your vegetable oil. So those are just a few examples. But your saturated fat being solid at room temperature, this is like if you think about cheese, and particularly cheese, think about pizza. What happens when pizza becomes room temperature? That cheese starts to become very solid because it's got lots of saturated fat. So when you're thinking about this, you're also thinking about meats, like marbling and meats in the grocery store, all saturated fat. So our bodies need to break that down. So when we think about these fats, I want you to think about how they're bonded together. So these are carbons. So if it looks like this, we have these carbons, right? And a saturated fat, and this is important, has not no bonds, but no double bonds. So no double bonds. And a monounsaturated fat, mono meaning one, has one double bond, one double bond. And a polyunsaturated fat has two or more double bonds. All right. So when we're thinking about that, these carbon-carbon bonds, if there is two or more between them, then it is considered poly. But if there's only one double bond, then it is considered mono. So it's really cool how these, the way it is connected together, that it actually changes its property from a liquid to a solid. So saturated fats have no double bonds at all. All right. So there are no double bonds in saturated fats. So when we think about fat and we think about breaking down fat, we want to think about, the foods that we take in. So if we think about this fat molecule, let's say that this is a lipid. All right. So this is a lipid molecule. And what we need it to become is we need it to be broken down into smaller portions. All right. So this here, this is not chemical, believe it or not. It's actually, I'm lying. This is chemical, but it is not enzymatically chemical. All right. So what we require for this substance, and I want you to think of salad dressing. Like if you think of a bottle of salad dressing, right? And you have the salad dressing is, let's see, you have your fat layer, right? So here's your fat layer on top, and then your bottom layer here, this is your salad dressing. So what happens is that you want to mix it all up, right? So that you can eat it. And when you mix it all up, well, this all becomes suspended, and we have a good mixture, right? So just think about this. This is this lipid. Well, the body kind of has to do the same thing. So this is called emulsification. The body has to break that fat up so it can suspend. So the way that it does that is it's going to emulsify the fat, right? So we have emulsification. And the job of this is bile. So we need bile salts. All right. And bile salts come from the gallbladder. All right. So bile is the key, bile from the gallbladder is the key to emulsifying fat. Well, just like your salad dressing, if you leave it sit, right, it's going to come back to this. It's going to settle back. So this is when the enzyme comes into play. So the enzyme from the pancreas is going to work on these fats like this, and we have lipase so that it can later be absorbed. And it's not going to be directly absorbed into the blood. It's going to be absorbed into the lymphatic system, as we had discussed before. So the pancreas produces this lipase that assists with this, and this will become eventually a micelle and a chylomicron. Those are two big words which we'll talk about when we get to the small intestine. Okay, so with this being said, we want to consider that with fat, so we have fat needs to be emulsified, so we have emulsification, right? And that is the job of bile salts. And then we also need pancreatic lipase. So pancreatic lipase is needed to break down these. So remember, the bile salts, these come from the gallbladder. So it's really important that we have the gallbladder functioning. If somebody has their gallbladder removed, then what happens is that there will be a connection from the liver to the small intestine. So we need bile and we need pancreatic lipase in order to digest fat. So let's think about that for a second. If we're thinking about this here, all right, and we said that the pancreas, I'm just drawing my dotted line, it delivers its content into the small intestine. So this is the pancreas, right? And up here is the gallbladder, up here is the liver. So here's the liver. We're going to be looking at this in our lab this week. So here's the liver, right? And tucked underneath the liver is the gallbladder. So here's your gallbladder, right? And it has a duct that kind of forms like this. So this is the first part of the small intestine, right here. So this is the duodenum. So here's your small intestine, and particularly the duodenum. All right. So what's happening is that when we eat fat, well, the pancreas is working to do its job, but the gallbladder has to be first. So here's the gallbladder, as we said, and the gallbladder secretes bile onto the top of the small intestine here. And then the pancreatic enzymes release their, their substances as well. All right. So we need that for, I'll write this down one more time, for fat absorption, we need bile and we need lipase. So let's say the gallbladder is not working, right? The person is experiencing a lot of pain, they're eating fat, and the gallbladder is not functioning properly. Well, what's happening is a person can end up with a fatty stool, because if that fat is not broken down, right, it needs to be broken down into smaller components. In other words, it needs to be emulsified. Well, if it's not emulsified, then the enzymes cannot work. So the enzymes are like this, like they're, they can't work on that. They can only work on these emulsified fat. So we need fat to be emulsified, otherwise it doesn't break down, it doesn't get absorbed. So if somebody had their gallbladder removed, then what we would do is we rely on, the liver just producing, because the liver makes the bile, but stores it. It only stores it in the gallbladder. So it's very capable of just secreting it on its own. Either way, that would be the liver's function.